Hello, everybody. We are taking a look at Section D, Unit D, and looking at triangle congruence. And last time we talked about showing all corresponding sides and all corresponding angles congruent. And if you could do that, then you could show that your triangles were congruent, or any polygon would be congruent for that matter. Today, we want to find out, is it possible to show less than 6 corresponding parts congruent and automatically ensure that all 6 parts are congruent? And the answer is yes. We don't actually have to show all 6 pieces, the 3 sides and the 3 angles, congruent, because sometimes we can show certain things and other things have to be congruent. So that's what we're looking at today. We're going to look at proving triangles congruent using the SSS, which stands for side, 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 and SAS, side, angle, side postulates. So let's take a look at the first one. It's called the side, side, side postulate. It says if 3 sides of one triangle are congruent to the 3 sides of another triangle, then the 2 triangles have to be congruent. Didn't even mention angles. All we really have to show are the 3 sides of one triangle congruent to the 3 sides of another triangle. Think of it this way. If I had you take 3 toothpicks and break them down into 3 different lengths, and I said, okay, put them together and make a triangle out of them. You would do that. It would be easy to do. You could make a triangle. Then I would say, okay, take them apart and make another triangle out of them, different triangle out of them. You couldn't. There's no way you could do it. Now, they might not be oriented the same way. You might have one flipped upside down, but the angles would still be the same angles because the sides will dictate how big the angles would be. So that's the idea of the side, side, side postulate. In the same way, we have the side, angle, side postulate. If 2 sides and the included angle means the angle in between the 2 sides, so the angle that the 2 sides create, that in-between angle. So if 2 sides and the included angle of one triangle are congruent to the 2 sides and the included angle of another triangle, then the 2 triangles are congruent. You don't need to worry about that other 3rd side or the other 2 angles. You automatically get the triangles congruent. I mean, think about it. If I can't change that angle and those lengths can't change, that's the only thing I can do is draw a line between B and C, and it would always have to be the same length because that angle doesn't change. So these things would all be congruent. And that's the idea behind the side, angle, side postulate. And now I'll get you going on your homework, your SWIC, and some other examples coming up here too.